little history. I recently competed in the NUSFintech2025 hackathon. I did this just after another hackathon, which due date actually just got moved, and I was completely beat. I was tired, I didn't want to do anything, but I still did it, and I pulled through with this entire project. Now, as of about 5 hours ago, I fell asleep. This ended up with me not being able to submit my project and missing out on potentially $20,000. Now, instead of crashing out over it like an edgy Gen Alpha teen, I have decided to continue on with my development and presentation of my project. So please enjoy. Alright, hello, my name is Jeremiah Pitts, and today I'm presenting for you a project that I've made for the 2025 FinTech Summit. So, this is my project. It is a blockchain and ML API solution for finance, and it's data-driven, transparent, and has a secure approach that allows for real-time fraud detection, KYC and AML compliance with immutable audit trails, and addresses critical needs in modern finance applications. Right. The finance sector faces numerous challenges: high-risk fraud in digital payments and lending, inefficient manual KYC and AML checks, and a lack of transparency in financial records are horrible pain points that we currently face today. With the rapid rise in transaction volume, scalable and secure automation solutions have become necessary. Not only this, but regulation has increased to the point where there are several different options and several different actions you have to go through in order to just make a simple transaction and log it. So this really proposes a solution. So my solution, it uses blockchain for an immutable ledger for transactions, with smart contracts enforcing rules and storing ML risk scores securely. For my API layer, I use REST and GraphQL endpoints for fintech apps, authentication, data aggregation, integration with ML and blockchain, and all alike. Now for my ML engine, I use predictive fraud detection and risk scoring, and the ability to switch between algorithms, random forest, XGBoost, neural nets. And as far as my late enhancements, which go along with my ML engine, an enhanced feature set including historical data and user profiling. Now, I use this for my general tech stack. So for smart contracts, Solidarity on Ethereum, Sepolia, or the private chain ML framework, which I use Python. My API layer uses Flask or Fast API. For deployment, I use Hardhat for contraction compilation and deployment. And for deployment, I use, again, Infura and Alchemy for remote Ethereum node. And optionally, you can use Docker and Kubernetes for scaling. I did not use Docker or Kubernetes just due to the time constraints of this hackathon. Now, data migration processes. So as far as the pros and cons of all the ones we currently use, traditional fraud detection, that is, without any blockchain implementation or ML, it's very established and integrated. As far as the cons, it's less adaptive and there's no on-chain transparency. As far as blockchain, it's trustless and immutable, which is a good thing, but it has limited intelligence and static rules. But my hybrid approach uses on-chain trust, off-chain intelligence, automated scoring, robust compliance, real-time analytics, and the problem isn't even picking between pros and cons. It's just pros and more pros, also coming with transparent and immutable audit trails integrated with AML and KYC automation. So any next steps in my roadmap, I will hopefully deploy it on a testnet integrated with the sample fintech front end, or refine ML models using more data sources, advanced techniques using stuff like XGBoost and neural nets. And as far as my scale, containerize it in either Docker or Kubernetes for high throughput, and add multi-chain or L2 support. As far as my expanded use cases, lending, trade finance, supply chain, cross-border payments, And for integration, integrate with sample fintech frontend. All right, so that was my presentation, and thank you so much. All right, so I do not want to expose any of my API keys or anything alike, so I'll be running it just like this. First of all, I'm going to start up my server. So I'm running python API underscore server.py. Now, what this will do is set up my endpoints. Now, I am going to run the commands found on my README. So first of all, here is my endpoint to record a transaction. So this is my first endpoint. Now I'm going to copy in that command, and this will record a transaction for me. Now you see the amount is 200 there. And block number, risk score, status, and transaction hash are all in there. Going back to here, this is how you flag or unflag an address. So I have that implementation in the API. And success. And finally, I have updating KYC information by storing a hash. Success.